Hi everyone, in the first diagram we are going to talk about net energy transfer. The red line refers to incoming solar radiation or insolation, while the blue line refers to terrestrial radiation or long wave outgoing radiation. We notice that between 40 degrees north and south, insolation is more than terrestrial radiation and the difference maximizes at the equator. This explains the oppressively hot climatic conditions in the equatorial region throughout the year. Beyond the 40-degree latitudes, however, things reverse. Here, sunlight is oblique, and because of that, the terrestrial radiation is more than insolation, which is clearly explained in this blue region. Now, before we can understand the location of the hottest and the coldest places, we need to be clear with a few things. The first is that high pressure means clear sky, which in turn results in rapid energy transfer, and low pressure means cloudy sky, which obstructs energy transfer. The second is the location of the pressure belts. Now, this representation is just illustrative. This is not how the real pressure belts look. Now this first line refers to the equatorial low pressure belts. Now despite having the maximum concentration of heat in the equatorial region as shown by this first diagram, the equatorial region does not have the hottest place because of the cloudiness in the region. At around 30 degrees north latitude exists the subtropical high pressure belt. Now, because of clear skies, there is rapid energy transfer which results in the location of the hottest place in North Africa. Now, we must not forget that at 30 degrees there is excess of insolation, and this combined with the high pressure, that is clear sky, results in rapid energy transfer which will be again incoming, which explains the hot temperature here. Now, the polar high pressure belt lies in the area where terrestrial radiation exceeds insolation, which results in rapid heat loss and thus the location of the coldest place. The reason why the hottest and the coldest places are located on land and not on water is differential heating. This means that land as compared to water gains and loses energy much faster. This differential heating also helps us explain the horizontal temperature distribution. In January, when the sun is in the southern hemisphere, land in the northern hemisphere will be colder than water at the same latitude. This means that if we are on land, the same temperature will be found at a much higher latitude on water. Thus, isotherms, when they cross from land to water, will move polewards. In July, the sun is in the northern hemisphere and land will be much hotter than water at the same latitude. This means the temperature on land will be found in warmer waters which exist in the equatorial regions. Thus, the isotherms, when they cross over from land into water, will move towards the equator. This will be the end of this video. Thank you.